Okay, quick video to cover some things about basic line graphs and something called stem and leaf plots that may or may not be something you've seen before. But it kind of all fits under this whole displaying and interpreting data concept as part of our stats unit. So this will be kind of quick. I'm just going to go through the basics that may or may not be reviewed. Graphs are a good way to display and analyze data. The graph at the right is a line graph. It shows trends or changes over time. There are no holes in the graph, and every point on the graph has meaning. To construct a line graph, include the following items. Make sure that your line graph has a title. In this case, if you didn't have this title saying that this was yearly attendance at movie theaters, you'd have no idea what they're talking about. That's important. A label on each axis describing the variable that it represents. The y-axis is the attendance in millions. The x-axis is years. Okay. Note that the graph at the right contains all three items. It does. Okay. Now, one thing I just want to point out that sometimes you'll see on a graph is this kind of like this break, and what that signifies is that you have to have equal intervals, and we'll talk about that in a second. So if most of the data was somewhere between 1.1 and 1.5, that's a very small interval. So you really needed to space it out by tenths, right? It's like 1.1, 1.2, 1.3. But from 1 to 0, we don't need to have all of that space where there's no data points. So a lot of times what they'll do is they'll use a page break meaning, and basically it's saying this is all equal intervals except we jumped right to the number 1. Okay. Now, technically, it starts from 89 and goes to 98. I guess someone else who made a graph may put another break there before the 89, signifying that from years 0 to 89, it wouldn't make sense to plot that information because we're starting with 89. Another person who makes this graph or another maybe textbook publisher might just kind of start it from 89 and call it good. It's not, either way is not necessarily right or wrong. So here's an example, and I'll go through. I've made a graph that you'll see, and you can take all the way from table form data to a graph. So the number of annual visitors in the Grand Canyon is given in the table at the right. Construct a line graph of the data, then use the graph to predict the number of annual visitors to the Grand Canyon in the year 2010. So this is older data. We're already past that. But anyway, year versus visitors. So the year is going to be the independent variable, which means that's going to be our x. The Grand Canyon visitors, that's our dependent variable, that's going to be on our y. We can see the spread is from 1.2 up to 4.8, so you could probably get away with scaling this from 1 to 5 or something like that. And we're starting from 1960 and going to the year 2000 on our graph. So let's see what I've kind of got done here. So we're going to draw a horizontal axis. We know that. We're going to plot our points, and then we're going to draw a line connecting the points. So here's what we've got. I have a title. Okay, let's think about those things that we needed to have. Have a title. I have number of visitors as my y variable, okay, in millions. I have years on my x-axis as my x variable. I've kind of cut and pasted my little table here, so I've gone from 1960 and I went up to roughly 1.2. Okay, I try to be as accurate as possible, but you're not going to be exact when it's decimals, unless you had made this much more comprehensive and had ticked out all of the tenths. But I didn't do that in this case. It wasn't necessary. I have a 1970 is right around 2.3. 1980 was around 3.8. 1990 was 3.8. I already repeated that. 2000 was 4.8, and I've connected the lines. Okay. So once you have information that goes from this form to this form, now you can clearly see some things. You can see there was a dip from 1970 to 1980. It looks to me like this is the steepest increase, so that's where it was the fastest growth. And you can see that it's increasing roughly in this range here. Okay, so that way you could kind of extrapolate this and figure out that in the year 2010, it's probably going to be somewhere around here, which would equate to somewhere around, what's this by halves? That's somewhere around 5.5 million, okay? I'm not sure what it actually ended up to be, but this is why a line graph is useful, okay? I think we've done line graphs before. You guys have definitely seen these things in middle school. Pay attention to the details, though. That's what really matters. You need to have a title. You have to have your variables labeled. Okay, and equal intervals is extremely important. You can't have two boxes that represent 1 here and then have one box represent 5 on the same graph. Then your line graph will not be accurate. Okay, another type of graph that is used to display data is a histogram. Now, in the last stats little video that I made, we talked about what a frequency table is. Okay, a histogram uses data from a frequency table and displays it over equal intervals. To make a histogram, include the same 3 items as the line graph: a title, axes labeled, and equal intervals. In a histogram, all bars should be the same width, no space between them. So in a nutshell, we don't have to get into detail. We're not going to go through from start to finish on one of these. A histogram is basically taking the data from a frequency table and turning it into a bar graph. So for example, this frequency table, I've grabbed this from a lesson from an older algebra book I used to use. That's why it's saying example 2 in lesson 1.6. You can disregard that. But it shows various time intervals that I think there was a science class and they rubbed balloons and stuck it on the wall, and they were trying to see how long each person's balloon stuck to the wall. Okay, so here's a frequency table that was made. So how many balloons stayed on the wall between 15 and 24 seconds? They made tallies. They said 8 of the students' balloons lasted that long on the wall. 9 of them lasted between 25 and 34. 7 of them lasted between 35 and 44, and only 1 from 45 to 54. Okay, so what a histogram is basically taking this information. Okay, this had a title, so this has a title. Okay, we have a vertical axis and a horizontal axis, the same. We have our intervals labeled with the same widths on the x-axis, and then we have our frequency number, which represents the y-axis. And essentially, it's just a bar graph. We've all seen bar graphs. So you just make the bar graph that represents what the frequency was. So it's really not a stretch to go from a frequency table down to a histogram. Okay? Histogram is just the bar graph form of a frequency table. Okay? The last thing that we're going to talk about for kind of interpreting data and how it's displayed is something called a stem and leaf plot. You may or may not have seen this in middle school. If you kind of pause this video and just look at this page right here, it kind of gives all the details of what makes up a stem and leaf plot. We have the greatest common place value for each data item is used to form the stem. The leaves are formed by the next greatest place value. In case the tens digits are the stems, the ones digits are the leaves. Write the leaves in order from least to greatest, and then they give you a key. So it shows you that if this were our stem and leaf, okay, forget about everything else, that means that 3 right there actually represents the number 23, because the stem is in the 20s, the ones digit is the 3, so it's 23. So once you understand that, it's very easy to look at a stem and leaf plot. Sometimes it just takes people a second to figure out what's actually going on when they look at it. So what this tells me here is that there is 1, 2, 3, 4, 5, 6, 7 numbers in all. Okay. The smallest number is 11. That 1 represents a 10 plus 1. That's 11. Okay. The next one is 16. The largest number is 45, and there were 2 45s. So if I wanted to recreate this list, it would be 11, 16, 21, 23, 29. There's no 30s, right? So then we go to 45 and 45. That's 1, 2, 3, 4, 5, 6, 7. That's how a stem and leaf plot works. Okay. So when you have things when the data is not in raw form, then you can answer questions more easily about it. That's the usefulness, that's the benefit of having different ways to display data, whether it's the line graph or the histogram or the frequency table, or in this case, the stem and leaf plot. So here's another example. I'm going to go through this one with you guys. The table shows the class results on a 50-question test. Make a stem and leaf plot of the grades. So we're going to arrange the leaves in numerical order to make the results easier to observe and analyze. So first of all, I'm going to try to identify the smallest number. Is there anything smaller than 13? No, I see a 13. Okay, so I'm going to do a 10 with a 3, which represents 13. I'm done. Now I know I have some 20s because I can see them right away, so I'm going to jump to the 20s. Okay, and the smallest one in the 20s, I have an 8 and 2 9s. I have 3 9s. Okay, so I think I have a 28. I have at least 2 29s. And it looks like I have a third 29. Okay, I'm going to move up to my 30s. And my smallest 30, I have a 34. And actually, I forgot a 17, right? But I can go put that back in really quick because I had a 13 and a 17. So my smallest 30, it looks like it's 34. And then it would be up to 37. And it looks like there's 3 of them. So 7, 7, 7. And I can go into my 40s, extend my stem and leaf plot. I'm going to start with a 42, go to a 43, and I have a 40 in there, right? So I have to back these up. Let's move this down. Let's move this down. I missed the 40. And I have a 43. Let's do a 45 and a 46. And a 48 and a 49. And I've missed a 35. So I'm going to go back. Whoa. My little slash on my 7s don't go with it. It's all right. And I'm going to put a 5 in here. And I think I've hit them all. Okay, so I'm going to double check my numbers so I don't make mistakes. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. This is 3 by 6, which is 18 numbers, so I'm good to go. If I were only looking at the raw data, it would be harder to answer some of these questions, but since I have it in a stem and leaf plot, what were the highest and lowest scores? Easy, 13 and 49. Which score occurred most frequently? Remember what the number that occurs most frequently is called. That's called the mode, and we're actually going to go through that in another video lesson for this stats unit as well. We're going to repeat stuff that I know you've done before, the mean, median, mode, range stuff. That will be in the next video. So which one happened most frequently? It looks to me like it's a tie between the 29 and the 37, so you could list both of those as the mode, 29 and 27. How many students received a score of 35 or better? Okay, so that's easy to pick out using this. Up here, it would be a lot harder to figure that out. But 35 or better, there's 1, 2, 3, 4, and then 5, 6, 7, 8, 9, 10, 11. So there is some usefulness to a stem and leaf plot, and you will have to kind of produce a stem and leaf plot on the assessment. So here's your opportunity. Just try this one. Write these numbers down, or you can just kind of, I know it's hard sometimes looking at a video, but stop the video, see if you can pause it so you can look at it. Try this on your own, and let's start the video over and see if yours matches mine, okay? So let's do stem, and we'll do leaf. We start, what's the smallest number? Smallest, I have 50s. Do I have any 40s? Yep, I got 40s. So I have a 41 and a 42. I'm going to go up to my 50s. I have a 54. I have a 50. I got two 50s, and I got two 54s. So 50, and then my 54s are gone. Okay. I have a 55. And I think now I'm up to my 60s. Looks like I have a 60, a 62, and a 68. And then I jump up to my 70s. I have a 70 and a 75. Okay? So if you tried this and then came back to the video, hopefully this is what you ended up with. Stem and leaf plot. Sometimes stem and leaf plots can be useful when you're actually trying to find the median, because remember when you find the median, we'll do this a little bit later, but you have to have things in order. So this also puts the data from least to greatest in sequential order. So that's it for this one.